So if you would like to follow the tutorial and the webinar at the same time, feel free to go to samsonconnect.net and then sign in. And you'll be able to download. I'm hearing us. So I'm also joined by another colleague, Jocelyn, that I'm hearing now. Hi, Jocelyn. So Jocelyn will be able to help you with questions potentially. And you can download SAMSON here, and then you'll have it on your computer and you'll start it like this, either on Windows, on Linux, or Mac. So I'll start it now to tell you about the new editors. So you know that in SAMSON, whenever you start SAMSON, SAMSON connects to SAMSON Connect to download all the new extensions and potentially offer you the update to the new version of SAMSON. The extensions are updated automatically so that you always have the latest versions of the extensions. But for SAMSON itself, you are offered to update and you can accept or not. And if you don't have this update offered, depending on your updating schedule that you decide inside SAMSON, you can always go back to the website and click on download to download the install. So now with the new version, SAMSON 2025 R2, we have introduced two new editors that help you navigate. So we have seen that sometimes some people who are used to visualizers software or software which were born as essentially molecular visualizers are used to some habits when they visualize molecules. Like for example, they use left click or just click on the trackpad to rotate the view. And so sometimes these new people or new users are a bit confused about the interface. So we added two new editors, like the view editor and the point selection editor, to complement the formerly present rectangle selection editor that we had initially. So that when you start SAMSON, it now asks you to choose which editor you would like to have as a default. So of course, you'll always be able to switch whenever you want between the editors, either by clicking here or by using the shortcuts like V for view, P for point selection, and R for rectangle selection. And you'll also be able to update your default editor by going to the preferences in the interface menu. And so what we advise is, depending on your habits and depending on what you want to do in SAMSON, you can choose one of these three default editors. So for example, if you're more wanting to visualize structures, we suggest that the view editor is going to be the most accessible for you, especially if you come from other software which do visualization. Let me just check that everybody's here in the Teams interface. Sorry, Zoom interface. Okay. If you want to do a bit of both, like design and visualization, like build some things or select some things, potentially edit or rotamer if you're doing biology, then maybe the point selection editor is the best. And if you're really into design, like you're building nanostructures, we know that some people here are doing this, then maybe it's better to choose the rectangle selection editor. So I'm just going to use the view for now. And anyway, I will change progressively during this webinar. So again, with the view, I left click to rotate the view editor. I left click to rotate the view. And if I want to know how to do the rest, I can use these tooltips. There are tons of tooltips in SAMSON, actually, that you can use always to learn more about things. So here you have a summary. So to pan, depending on whether you're using trackpad or a 3-mouse button, so we recommend a 3-mouse button, but 3-button mouse, sorry. But if you don't have that, it's also possible on the trackpad or with a mouse that has fewer buttons. So you have all these helps here. So rotate, click, drag, this. On the trackpad, to drag, you would either do like Shift, Command, and click, or command and right click, so 2 fingers at the same time. Okay. I'm going a bit slowly for now because I'm waiting for more people to join in. Okay. So remember, you can always switch while you're using SAMSON, using shortcuts or using just these editors here. So remember, on the left, you have all the editors available, potentially the ones that you have added also from extensions, like the add init extensions if you do DNA origami. And you can also go to interface, sorry, preferences, to change in the editors part, the default part, which editor you would like to set as default.
Stefan, can you share your screen, please?
Start SAMSON, but also when you want to go back to an editor, like for example, let's say I'm currently using the add editor to build things. When I press escape, I go back to the view editor, to the default editor I have chosen. Okay.
Stefan,
yeah.
Can you share your screen, please?
Sorry, I thought I was already sharing my screen.
Thank you.
Sorry, so my screen was not shared?
Just at the very beginning, and then...
And then it was not shared anymore. Okay, I'm sorry about that. So just very briefly, I chose this view editor. I can switch between these 3 editors. And I can also go to preferences to choose the default editor. So the default editor is the one that comes when we start SAMSON, or also when we press escape to go back to the default editors. For example, if I'm adding structures and I press escape, I go back to the view editor. Okay. So you didn't miss much because I didn't load a molecule yet. I'm going to do that now, but please let me know, and sorry again about this sharing issue. So I'm first going to open a document that contains a protein, PDB code 121P, if you'd like to download it at the same time. So in a new document, you would do fetch to fetch from the PDB, and you would enter the code 121P and press load. Okay. So the first thing I would like to show you is this new visualization feature that we added to do progressive clipping. So what we mean by this is that you know that typically in software, you have the possibility to remove parts that are in front of the thing that you're looking at. But typically, it's a sharp transition, like the structure is cut, and it's hard sometimes to understand really what has been cut or what is just absent. So to make this more clear, we have introduced this new feature called progressive clipping, where something is clipped partially depending on its distance to the camera. So for example, you see that here, this oxygen atom is partly clipped. This one here too, this one here too. On the border, things are not clipped so that you know that things are being clipped thanks to this transition. And so basically, when I rotate the view, I see things progressively appear and disappear from the view. Am I still sharing? Just checking. Okay. Let me move the Zoom interface. So you can control this progressive clipping. So basically, it's proportional to the distance to the camera. So you see that this helps me better understand where I am and what has been cut from the view. And to adjust this amount of clipping, I can either on Mac press Command and use the trackpad to zoom and unzoom to move the clipping distance. or using the control key on Windows and Linux. Or I can use this icon here, this new icon in this bottom toolbar that helps you control the view, to adjust the clipping distance and also the fog distance. So the way this works is you have two sliders where you have a representation of the camera eye, the eye position, the camera target, the thing that's currently at the center of the screen, and the background placed at an infinite distance. So you see that using this slider, I can adjust this clipping distance, and basically it can never go beyond the target, like the position of the camera. And also, I can also adjust the fog distance to hide the things that are in the background. And if you want to do that with a shortcut, to adjust the fog distance with a shortcut, use the Shift key, so that if you press Shift and Command or Shift and Control at the same time, basically you adjust the size of the slab, of the viewing slab. Okay. So for example, when I go down on the trackpad, I have a very minimal viewing slab. And when I go up by pressing at the same time Shift and Command, I have an increasing slab. Okay. So using this, you can very rapidly control what you view and make rapidly images. So let's say, for example, I would change the background, maybe change a few options, like add silhouettes, maybe apply a color scheme to the secondary structure. And then maybe I would like to see what is close to the ligands. So I would go to select, select menu, biology, binding sites, and then maybe I would select the labels here, or just based on the selection, I would apply labels on all the residues in the selection, etc., etc. And again, even if I rotate, I will be able to control the clipping so that I don't have things hidden in the view. So, of course, this is SAMSON, so you can customize lots of things, and in particular, the style of the clipping. So to do that, you either go to interface preferences or you directly click to this setting on this setting icon, and you reach these custom parameters, that you can control. So for example, you have some default, some predefined settings, group of settings. For example, this one is the default with halftone pattern and some border size. Let me change here. So you see that, for example, here, this part shows me a border that it indicates that something is being clipped. So I could decide to remove this border by setting the border size to 0. I can also go back, if I wanted to traditional clipping, but you see that this is not very nice because it shows you the polygons used to draw the shape, plus it gives you a very sharp transition. It doesn't give you indication of the depth of things. So you have several types of confirmation like this, of settings, presets that you can choose. Okay. So this is for progressive clipping, and again, we encourage you to play with it because it's very, very convenient to see things more clearly when you're zooming on something, especially a ligand, for example. Okay. So now I would like to. So if you have some questions, I'm assuming that Dima and Kate and Jocelyn are helping you right now, but I'm going to move on to the new quick groups. So something that's very useful when you work on a design or when you want to understand a structure or you want to show structure to colleagues is to be able to rapidly switch between selections. So as you know, selections are very, very important in SAMSON, and you have many ways to select things. So either with the point selection editor, the new editor, or the rectangle selection, or you have a selection language. So let's say residue type alanine, and you press enter and all the alanines are selected. Or you have also lots of selection commands, like for example, binding site. And by the way, whenever you hover and you have the tooltip, you see the node specification language string that corresponds to that, the NSL string. So node type residue with the 500 node category ligand, etc., etc. But sometimes, and you always had the possibility to create groups by pressing the G key, which saves a group in the document, that you can double click to restore the selected groups, the nodes from the saved selection. Okay. So you can do this either by pressing the G shortcut, or in edit, you, sorry, group, where is it? Sorry, in select, of course. You save a group in, when something is selected, in the group command here. Okay. I love using shortcuts, so I even get lost sometimes. By the way, when you get lost, you can either ask SAMSON AI, so how can I create a group? And it will tell you and give you direct access to the command. Or you can use this find everything box here. You type group, and you'll find everything that's related to groups. For example, of course, the first one, the group command. Okay, so you have lots of help to get to find things. But so these were the traditional groups. Now you have a new way to create quick groups that are unnamed and that are shown here in the bottom part of the document view. So to do this, let's say, for example, I select these atoms, or maybe I select this atom and then I select the connected component. There is a covalent bond between the structure, so it selects a lot. So let's say I select just this. Then I can either go over this group here and press Shift and click it. And you see that now it's active. Or let's say I select another group, I do another selection, so maybe receptors. Instead of going over here and clicking while pressing Shift, I'm just going to, with my keyboard, press Shift 2 to assign to the second quick group. Okay. And now, by just using the keyboard shortcuts 1 and 2, I switch between selections. Or I can just click on them here. Okay. So this is very convenient when you want to rapidly do modeling tasks like applying visual models to something or moving to a selection. So in particular, if the camera view is not centered, let's remove this. If the camera view is not centered, let's hide the labels. When I double click on a group, like let's say I double click on one, it zooms to the quick group. And of course, this works also with a keyboard shortcut. So I can double press 2 to have the view centered on quick group 2. Double press 1 to have the view centered on quick group 1. So this is really very convenient. If you play video games, you might have seen this in real-time strategy games. This is really very convenient to switch between groups. Let's say I would now select water here and assign this to group 3. Now I can rapidly switch between different views. Let's say I want to, so I select water with group 3 and I apply on a Valls model, and then I select the receptor and I apply the ocean surface view, etc., etc. Yeah. By the way, we can change the clipping to see inside the surface and while rotating the view. Okay. So again, this is very convenient when you work with things. Let's say I select one again, I zoom, two, etc. Okay. So let's save these, close these documents, go back a bit to default rendering settings. And now I'm going to move to the next part where I'm going to tell you about the protein aligner and different color schemes. So for that, I'm going to open a new document. Which this time, let's remove silhouettes for now, which this time contains 3 related protein structures. So 121P, 1R2Q, and 1J2J, which have not been prepared at all. Again, I've just loaded them using the fetch command in SAMSON. Okay, and I entered the PDB code here. Okay, so you see that these protein structures are completely unaligned, and it would be hard to know, I mean, first, unless you're a specialist, to know that they're related, they have similar structure, partly. So what I'm going to do is first clean them, clean the structures. I'm going to use the prepare command, where I'm going to choose what I do on the system to prepare it. So I'm going to remove alternate locations. I'm going to keep the ligands. So I'm unchecking this box. I'm going to remove the water and the monatomic ions, and I'm not going to add hydrogens. Okay. So this is a bit cleaner. It shows me a bit better where the ligands are, where the structures are, but it's still very confusing. Okay. So another thing I'm going to do now is I'm going to show you about these new color schemes that can be used to color per structure. We have, you might know that we have lots of options to color in SAMSON. So for example, I could select this ribbon structure and color per attributes, let's say color per residue hydrophobicity. We have lots of commands to choose color schemes and colors already, but 2 new color schemes are, let's read this one, to color per structure with a default color scheme, or per structure with color with an illustrative style, which combines a fixed color with a special case for hydrogens. So it's basically inspired by the PDB image of the month, molecule of the month feature on the PDB website, and by Goodsell style, which is super popular and super beautiful. So here directly I see better where ligands belong. I see which structure is which, etc. Okay. But I clearly see also that these structures are completely unaligned. So I'm going to open the aligner, which is now with SAMSON 25, a default tool present in the home menu. So when I open the aligner, you see that I have several commands, and the main 2 commands are these ones: align sequences by structure or align sequences by chain. Because depending on the scenario, sometimes you want to do different things. Here I have 3 different structures which only contain 1 chain each. Sorry, this one has 2 chains. So that's actually going to be interesting because I'm going to align the structures themselves and not the chains inside, so that the 2 chains in this 3rd structure will move together. Okay. So to do this, I just click Align Sequences by Structure, and now you see that all 3 structures are aligned. Sorry. And let's close these to have a bigger view. By the way, in SAMSON, you can always get rid of the interface. So either if you want to get rid just of the menu, you can double click it to hide it and just keep the names. Or you can click this eye icon to get rid completely of the interface, and you click it again to show it back. And when you want to keep only something while in full screen, you click the pin icon here before going to full screen. Okay. So let's go back here. So you see that now I have the alignment which has been computed. I can select things, and selections are synchronized, so that, for example, this part here would be selected in the first structure, but also elsewhere, like here in the second structure, etc., etc. Yep. So the first thing I can do before alignment is understand a bit better the structure by highlighting residues based on properties. Like, for example, if I want to know which ones are hydrophobic, which ones are polar, which ones are positive, etc., etc., I can select this. And then I can also transfer this when I have the sequence view. Maybe I could show that actually in the sequence view at the same time. So let's go right click here and I click view. I have this sequence. Let's say this is selected. Let's say I highlight some colors. Let's say positive, negative. And this will be shown here, but of course this is not visible because of the color schemes I have applied before. So I'll just reset. And so you see that now here I have residues color coded by physical property. Yep. But let's go back to the aligner. Now I can choose, let's unselect everything. I can choose to which protein I align. So let's say I select this one. Now you see that this chain moved along with the other structure. All proteins are aligned and ligands as well, so I can have a better comparison of them. Okay. But I could, so this shows me the distance. So since I clicked on this one, on the first one, I aligned to the first structure. So it shows me that the second structure is at 1.75 angstrom of RMSD of the first structure, and the second one is 4 angstrom of the first structure. I could align on this one instead. Of course, I would get similar results, especially for the extremes. But what I can do also is select a subset, a subsequence, to only align on that part. So for example, if I press Shift, so Shift space zooms to the selection, or you can also use these commands here, zoom on selection. Okay. So this is actually a loop, so it's not very interesting. Let's select a different part, like maybe from this part. So let's go to point selection and then go to selection filter residue. And I would select this residue. And then this one, this one, this one. So you see that they become highlighted here. I wanted to see which they were corresponding in the sequence. Let's align on this. Now you see that these helices are perfectly aligned and the rest moved accordingly. Okay. So you can precisely control on which part or subpart or on which protein you align your structures. Okay. I'm not checking the chat at the same time. Actually, I can do that, but I trust my colleagues. Okay, so let me close this document. And now I would like to show you what's probably the greatest novelty in 2025 is the interaction diagrams. So most of the time when you want to study structure, a biological structure with a protein and a ligand, you want to understand very precisely the interactions between the ligand or ligands, and the pocket, the surrounding protein, and you want to understand the different types of interactions that can be, like potentially hydrogen bonds, amide bonds, etc., etc. So to do this now, you have this diagram command in the home menu as well that you can use to automatically generate all interaction diagrams between all ligands and the protein. So it's going to do different things based on what's selected. So as always in SAMSON, when you do something, either something is selected and what you do is done on the selection, or nothing is selected and what you do is done to the whole document. So here, nothing was selected, so it generated all interaction diagrams for me. So for example, I have some sulfate ions in the structure, so it generated these diagrams. And I also have a big ligand, so it generated this interaction diagram. Okay, so I could make this very big. I could edit here, reframe the view. So you see that here I have the details. Let's do it just in 2D first. I have the details of the interaction between the ligands and the surrounding protein. I'll just do it in 2D first. This diagram is completely editable in multiple ways. So first, visually, and second, in terms of the parameters that define the interactions themselves. And I'll show you that after. But first, you can zoom a bit more. You can decide what you want to see in the diagram by clicking in the caption, in the legend. So for example, if I want to hide clashes, I click on the clash name, and it hides this clash that was visible here. Same for halogen bonds, same for donor-pi interactions, pi-pi interactions, etc., etc. So I could decide to hide them all first, and then go one by one, and and then only see which residues are surrounding the ligand. Okay. Another thing I can do using the caption is double-click to change colors. For example, let's say I decide, so I change this earlier to make it more visible, but maybe I'm thinking that it's a bit too flashy. So I'm going to double-click this and change the color to something which is a bit more like the default color, which is a bit more orange, okay? Maybe I like clashes and I think it's something very positive and I put it green or something a bit nonsensical, I hid it. Oops, sorry. And now that's not visible, so you have to think at what will be visible in a publication, for example, so it's better to preserve contrast, for example. Okay, so everything is customizable. You could change the colors, so you can activate also backbone interactions or sidechain interactions, only keep the ones you want to see. And also you can move all these labels and even all the labels of the interactions themselves to position. So there is an advanced layout algorithm that tries to place everything, but sometimes there are just too many interactions and they're potentially overlapping each other, and you might want to show many things. So like sometimes in some tools, you only see a few interactions So it's rather easy to show these interactions and to organize them. But here it gives you the possibility to show many different types of interactions. So that's why we give you a lot of freedom in how you place everything so that you can really do the diagram as you want it. Okay. So that's the first type of customization, like placing all labels, all interactions, hiding, showing stuff. Like for example, let's hide solvent accessibility. Let's hide the pocket, show the pocket. So that's the first type of customization that you can do. Okay. The second type of customization that you can do is controlling what interactions mean. So to do this, you click on the gear icon. Now you'll see that some apps have a gear icon here, which directly leads to the corresponding page in the settings. And so here, for example, you have lots of settings to define the interactions themselves. So for example, you could decide that the interaction distance threshold is smaller. And if you do that, you will see fewer interactions. You'll see it's updated automatically. You'll see fewer or more interactions in the diagram. Okay, so this can also help decide what is visible in the diagram or not. Okay. By the way, when you want to reset to go back to the default value, you see that on this setting here, when I hover the label, I have a little arrow, curved arrow. If I double click, it goes back to the default value. Okay. So by default, we detect interactions at 3.6 angstrom. Okay. And you'll have few options also to decide whether you want to sanitize or not. By default, these are unchecked because you should, like we try to trust as much as possible what you open inside SAMSON, but you could change this in the settings. And you also have some layouting options as well as some settings to choose the capture size when you save the interactions. So you can save this diagram by clicking the save icon here in different formats, either as a SVG or as PNG. You can also control more precisely what you want to show interactions with. So potentially sometimes you have multiple structures at the same time, potentially because you have done protein alignment and you have multiple ligands potentially interacting with multiple proteins. So by default, let's say go back again to this unaligned proteins. I align them. Here, if I clicked on the diagram icon, it would show me not only, it would show me all possible combinations. So it would show me the interaction of ligand from 1 to 1p with potentially protein of 1R2Q. Okay, but I don't necessarily want to do that. I want just the interactions internal to 1 to 1p. So for this, I would click 1 to 1p and then we'll click on diagram. Okay. But when you have already a diagram, you can update what is considered as a ligand, as the molecule for which we want to know interactions, and what is considered as the environment. Okay. So for example, I could create a new diagram that's empty. And here, let's say that this would be the environment. Then I'm going to have to find the ligand that I guess is at the bottom before. It's actually, so a little trick. You could, let's choose point selection. You could click on something. I'm in residue mode. Let's select any node. You could click on something and then right click and say show in document view. And you see that it will show you where it is in the hierarchy. Okay, so here I have GCP. Let's say I click this as the ligand. And since I had selected before the environment, like the protein to which it belonged, it shows me the interactions between this ligand and the bucket. Okay, but if I hadn't done that, potentially it would show me much more, many more residues, which would belong to the other proteins that have been aligned to 121P. Okay, so let's go back to, let's close this one and go back to the other document. Of course, what I wanted to show you is that these interactions are shown not only in 2D, but also in 3D. You see that here, when I zoom, sorry, when I zoom here, I have all the interactions shown as well and synchronized with the 2D view. And I can hide them or show them as well. So you see that, for example, here I have these carbon pi interactions. So we try to make the symbols as explicit as possible. So you have like a aromatic ring and a C inside to say that this is a carbon pi interaction. I could hide them both in 2D and 3D, okay, and to focus on which interactions I want to analyze. By the way, I could also apply a visual preset here in Visualize, protein-ligand, so that, and then I would hide this, so that it would show me also the side chains of the interacting residues in the binding site. So if you don't know this, just a brief reminder, in SAMSON, you can apply visual presets which correspond to a series of steps where you select something, you do something with this selection, and you visualize it and you colorize it in some way. So for example, here, if I examine the protein ligand preset that I just checked, what it did is these 6 steps, where in step 1, for the receptors, it hides them, and then it visualizes it as ribbons, and then it colorizes it white. Okay, but I could edit these steps and do my own visual preset. And then even if you close SAMSON, and when you restart, they're still here. So you can very rapidly create visualizations that you like, and that correspond to your style of images and publications. Okay, so here, when I use this preset, I see the side chains in the binding site. I could label them as well. Let's do that at the residue level. So let's say this one, this one, this one, this one. And now I have better information on what is interacting with the ligand. And also, I don't know if you've noticed already, whenever I hover something, it highlights everything that corresponds to the interaction. So for example, here, when I hover this carbon pi interaction, it highlights both in 2D and 3D, this leucine 844 and the rings. And if I double click, it zooms to it. Yeah, if I double click on this atom, or this atom, or even on this here, I could go to directly, if I hover this interaction, carbon pi interaction, if I double click, it will center it. Okay. So again, lots of things to play with. And so either to use these publications, potentially showing both 2D and 3D interactions. And again, lots of possible customizations. Okay. Okay, so now finally I'm going to move to the last part, which will be less bio and more about, say, nano design, but you could use this for bio as well. I mean the pattern builders. So SAMSON is used for many, many different applications for bio, but also material science and like DNA origami and building nanomachines. Some people here do very advanced designs that we're always impressed with. So what I want to show you is how to quickly use these pattern builders to create advanced structures. So what I mean by pattern builder is going to be a repetition of things like a pattern, either linear or circular or curved, that you can use to rapidly build structures with hundreds of thousands of atoms. So for example, let's say I do something very basic. I just create a little molecule just to explain to you the idea. Let's say I do a little molecule and I minimize it. Then I could select this and let's do a top view. Let's unzoom a bit and select the linear pattern builder. And you see that here I have by default 10 here. I have a total of 10 replicas that are shown that I can control. I can edit. Let's close this to give me a bit more space. Let's just go full screen. I can control the position of, oops, sorry. I can control the position of the replicas to edit the pattern. Sorry, my computer, I think Zoom is making me do weird things. My computer is getting super slow. I think there's something weird going on with Zoom. I hope it's still okay with the sharing. Let's see what's going on. So here I can click. Yeah, sorry, it seems to be doing something weird with Zoom. It's not very responsive anymore. So when, I hope you're seeing this, when I'm dragging the structure, I edit the linear pattern and I can place it like I want, but I can also rotate things and control the incremental rotation that happens from one replica to the next. Yeah. Sorry, I don't know what's going on. So I think Zoom, I should check the activity monitor. Let me stop sharing and check this for a minute. Sorry, Zoom is taking like 60% of resources. I don't know what's going on. Sorry about that. Let's try again. Sorry, let me restart the sharing then. Okay, so let's try, I don't know if Zoom will let me do that. So this seems to work better now. I can translate, I can rotate. Hopefully you're seeing this. So this is for the linear pattern. So you can do it manually to adjust things visually, or you can also click on here to edit precisely the parameters of the pattern. So for example, you could change the number of instances, you change the displacement. So let's say I want a distance of 2 angstrom in the x direction, and I want 0 rotation. Maybe let's increase a bit. Then I press OK. And then when I accept the pattern, things are built. Okay. And you could do this with a curved pattern. So this will not be closed. It will, let's say, if I do a rotation, let's center. I'm really sorry about what's going on with the zoom. You see that if I change this curve, this rotational increment, then I can do potentially advanced patterns like a DNA curve or something like that. Okay. So what I'm going to do to conclude the webinar is show you the hard way to do nanotube. So we have a nanotube creator app, which is free, that you can find in SAMSON Connect, where you basically choose the nanotube parameters, and very easily you have a nanotube, and then you can play with it and let's say like distort it like this, change like deform this nanotube, etc., etc. Okay, but let's not do that. Let's do it as let's say nano designer would do it potentially. So I'm going to start from a ring where I'm just going to place a ring here, and then I'm going to, let's say, select all hydrogens and delete them. Okay, so I have this ring, and I'm going to orient it in a different way. Let's say I place it like this, rotate it a bit like this, and then from the side view here, I'm going to make sure that its borders, its sides would align. Okay. So let's say I have this ring now. Here it's not really well aligned. By the way, you have lots of new tools to align. So you could decide to in edit to align this. So I guess here, let's first align it. So I would align it with the Y and Z plane. That's already considered a line. So it's too small to have enough information about the general orientation of the ring. So I'll just do it manually. Okay. So now if I select it and I apply a circular pattern that I make a bit bigger, you see that I can superimpose the sides of the ring. Okay. So let's just make it a bit bigger. Let's say we want 12 instances, and I change the position. I superimpose the sides of the ring, and then I'm just going to click accept. Okay, and now these atoms which were close to each other have been merged and have a single ring. So let's align the structure. So let's go back to the view editor for now. I'm going to first align with the origin, then align, let's say, in the XY plane. And now I'm going to apply a linear pattern to make it go up. So to do this, I select it, I apply linear. And you see that by default, it always goes in the X direction. So I could manually move it, but I'm just going to, I could manually move it like this, okay, and prepare my nanotube. Okay, but I want to be precise, so I'm just going to say that I'm clicking on this widget and I have 0 translation on X, 0 translation on Y, and then maybe 2 angstrom of translation on Z, because you see that due to the way I have done my pattern, I need to rotate each replica before, if I want to be able to merge it. Okay? So to do this, let's make it go back at first so that I can see better what I'm doing. To do this, I'm going to go here and rotate a bit so that there is a perfect alignment between what I want to merge. Let's say this is sufficiently okay. Now I go back down. This seems rather okay. It's not perfect, but I'm going to click accept. And now you see that I have a nanotube. And so it's not completely straight. I'm going to minimize it. So I go to edit, I click minimize. It tells me that some hydrogens are missing, which is fine. I'm going to click accept. And now it's minimizing the nanotube. Okay. And potentially you can use this to, let's add hydrogens on the border. Let's change the representation. You can do this to do more and more advanced shapes. And I invite you to see the designs by Tom Moore, for example, on Twitter. I'm not sure I'm going to be able to remember the handle on Twitter. I think it's Moore, MOORETH 42 on Twitter, but please confirm that in the chat. And you'll see super impressive nano machines. So that's it for today. Thank you very much. Please don't hesitate to send us any questions, so either now in the chat or through email at contact@samson-connect.net. Or, you know, in Samson, you can always click send feedback, and then all the developers receive your message.